There we go. Excellent. We're going to have 4 main topics in our 1-hour discussion. These are a selection, my personal selection of, I suppose, 4 of the bigger things going on right now in leak detection systems. It's an active field, obviously, so this is, again, a personal selection. I think that some of the important things that are beginning to roll out are the API recommended practice 1175, which covers leak detection programs as part of overall management of leak detection systems. Another thing that's about to be published is that PHMSA has sponsored leak detection guidance and documentation advice, and that's likely to be published towards the end of this year. So I'd just like to give folks a preview of what to expect there. The API technical publication 1149 was also recently updated. That's one of the most important publications that folks use for trying to predict the performance of leak detection systems. So clearly, I think that the update is something that is fairly significant and topical. And towards the end, I'll do a little bit of crystal ball gazing to kind of see what we think the current and impending PHMSA rulemaking might be for liquids and for gas pipelines. So what I'll try and do, just like Robert said, please do go ahead. No, it's a little button on the right of your toolbar. It's called questions. Now it's going to be 1 hour long, so it's going to be about 15 minutes per topic. I'd like to take those questions, so in between the topics I'll probably take a little break and perhaps read through them and see if there's any that we could talk about in front of the whole audience. Other ones we'll probably just type in a direct answer to you if you'd like to keep it private. I also want to say that this is an issues and options style discussion, and if there are any opinions as such, the opinions are entirely my own, so not necessarily sanctioned by Technical Toolbox's PHMSA or anybody else. So the preliminaries out of the way, I did want to sort of have one slide which is kind of explaining kind of the framework of why we're doing all of this. Leak detection systems are often regarded as a necessary evil because they don't of themselves make pipelines any richer. They're just an expense. They are a continuing expense. They require staff and training and technology and investments. And they don't make you pump any more oil than you did before. On the other hand, what leak detection systems do is to help manage the risk, the business risk of running and operating a pipeline. And to hammer this home, the third point is that regardless of how impeccable your maintenance program is going to be and how good you are about corrosion mitigation and how good you are about inspections, your pipeline will end up leaking. Somebody is going to drive a backhoe into it, and something will go wrong regardless of how well you are. So in that light, you need to have not just a leak prevention program, which is important. You also need a consequence mitigation program for that day when the leak will occur. And leak detection systems are step one in any consequence mitigation program that is possible. And every responsible pipeline operator maintains some sort of risk management contingency kind of plan. Leak detection, therefore, is part of that strategy within all pipeline companies. So with that kind of piece of motherhood out of the way, let me start on the topics. Remember the 4 topics I was going to cover. And this one was the API, American Petroleum Institute Recommended Practice 1175. And what it is the establishment of a framework for leak detection program management, LDP. It's an API recommended practice, so technically speaking, it is directed to liquids pipelines. It's also, technically speaking, directed to liquids pipelines which are federally regulated. So, typically speaking, liquids pipelines in high consequence areas. However, let's make a few clarifications here. First of all, the leak detection program itself is a good practice regardless of what kind of pipeline you're operating, and the principles apply, at least in my opinion, 100% well to natural gas pipelines, just as well as to liquids. So this is a valuable piece of work for the entire industry. Now, what is a leak detection program? By the way, LDP was kind of christened by the API 1175 committee, but the first point to make is that a leak detection system is a complete system. It consists of a technology, it consists of processes and procedures, and it consists of people. And if you break any one of those 3 major areas, then the leak detection system will fail. And there has been, at least the feeling of the API committee was that there was a great focus on technology. So people were hoping that they would be able to go out and buy a leak detection system, switch it on, and have effective protection against leaks. Now, in recognition of that, the API tried to focus a little more on the processes and people side of this equation here. The other things that are important in a part of the program is to observe that many technologies rely on other systems for them to work, and the classic one is computer-based pipeline monitoring. You're relying on metering, your measurements, on SCADA systems, on telecommunications, and alarming. So there's a number of ancillary processes which are going on in parallel with your leak detection technology itself. I did mention that one other thing that the API recognized is that fairly good leak detection systems have often been let down by a casual attitude towards personnel training and or response procedures. And so the emphasis here is to try and make sure that the rest of the system is not let down by ignoring those factors. And then I think the final thing that's important is, like all systems, you can't just sort of fire and forget a leak detection system. It's important to keep a full life cycle approach to it. The other thing it does have is a technology selection chapter. I did want to highlight this because the attitude of industry has been that there's plenty enough technology out there. What is missing is a strategy for selecting the correct technology for your application. To quote PHMSA itself, the operator's choice of methods, in other words, the technology to be used, is completely dependent on the type of pipeline construction, how it's operated, the environment in which it finds itself, and so forth. So there is a specific chapter in 1175 which deals specifically with technology selection and how you go about it. Now, here is a quick rundown of the major chapters, and you'll see that this is fairly novel for an API recommended practice, because the first one, the first chapter, is specifically directed towards how do you establish, maintain, and nurture a healthy leak detection culture and strategy. In other words, don't turn it into the ugly, boring, necessary evil, red-headed stepchild part of automation and control, let's say. Turn it into something which is a positive, proactive way of managing risk on your pipeline. I did mention there's specifically a chapter on how to go about selecting leak detection methods. Now, this is not a cookbook. It's not structured with a kind of strict methodology or anything like that. But what it is it's guidance on how to go through the correct steps and the correct processes for making sure the leak detection method is appropriate to your pipeline. The third bullet is also often ignored or overlooked, and that is to sort of not only estimate how good your leak detection system will perform, but also to how do you decide whether the performance is good enough? In other words, what targets to set yourself? How then to measure the performance once it is installed, and how to develop key performance indicators for the performance of your leak detection system over time. And these are topics which are normal in nearly every other branch of engineering, but once again needed spelling out, I think, in the case of leak detection systems. Specifically, how do you test a leak detection system? How do you know it's actually effective and providing you with the risk mitigation that you hope for? Alarm management is very important. One of the big bugbears of leak detection systems is not perhaps the lack of sensitivity. It's more of a lack of reliability. So the leak detection systems which continually cry wolf are typically ignored. So alarm management is a special area where the alarm that comes from the leak detection system is rapidly corroborated by operators and by other ancillary systems too. The final chapter is reliability-centered maintenance for leak detection equipment. And that, like I mentioned earlier, is not to ignore the fact that the leak detection system will itself rely on other systems for its own performance, and therefore the leak detection engineer and group at least has to keep track, if not directly maintain those equipment themselves, they do at least have to be able to track them effectively. It was a multi-year cross-industry development program. At least 18 pipeline operators contributed. I mean contributed. Certain pipeline companies were actually tasked with writing sections and subsections of the chapters that we just went through. It started in late 2013, but they've been talking about how to set this up perhaps for a couple of years before that. So I would say that the 2 years on paper that it took to prepare is probably only half of the total time that went into its development. One final thing for everybody in the audience to know is that I think uniquely for API, the recommended practice is being published. There is a second team right now which is promoting and rolling out this particular recommended practice. So this takes the form of seminars, training programs, and so forth, intended to jumpstart other operators into a leak detection program philosophy. And so this assistance is available from a volunteer force. They are industry, they are pipeline operators, but they are all being supported by API. If you yourself would like a quick seminar on this on an ad hoc basis, at the next API Pipeline Conference there will be a one-day training course on the API 1175. Quickly before moving on from this topic, I also wanted to point out, remind people that there is the API recommended practice 1130, which applies specifically to computational pipeline monitoring. By computational pipeline monitoring, I mean this list here of techniques which can be used typically on liquids pipelines. And this is kind of very tightly dovetailed into API RP 1175, especially the very last one, which recommends the testing during commissioning and every 5 years, and other items which apply specifically to CPM. And I do highlight this again, as I say, because it is so common. The other one that I would mention is the 1149, which we'll talk about later on in this hour. And then a weakness, I suppose, in the whole of the suite of recommended practices. We do not have API, or rather recommended practices, as such for external style leak detection systems. I've written down here a couple of references, but they do not hold the status of a recommended practice by any means yet. So one thing, I suppose, if I was to crystal ball here with the API, is that the next thing that we could perhaps look forward to would be a slightly fuller set of recommended practices for external systems as well. Now, I'm going to just take a break there before we move on to the next topic, and let's just see if there have any questions. There have been no questions. I trust that's good news. Once again, even if you have something general to ask, simply go ahead and type it in on the little questions page on the side of your screen, and I'll be glad to, during a little pause between topics, I'll be answering those. So let me see if I can get my screen back. There we go. Whoop. There we go. The second subject I wanted to talk about was kind of similar. PHMSA has been sponsoring a leak detection R&D and guidance, and the mouthful of a title is Improving Leak Detection System Design, Redundancy and Accuracy. It was similar, it's kind of in parallel with API RP 1175, but I'll talk a little bit about where they dovetail, where they overlap, where one sort of fits in with the other. But this was a PHMSA-funded activity, but it was actually, once again, performed by a technical committee of 15 pipeline operators, but also state regulators and PHMSA's own R&D, engineering R&D organization contributed as well. During the process, technical standards agencies, the vendors, the technology developers, and also testing agencies were interviewed, were involved, were asked for material development and so forth. So this was kind of a little bit broader, if you like, in audience. And what was it for? So the idea was to develop a set of recommendations, guidance, and draft procedures, which I'll talk about in a minute, related to leak detection systems, and it was really related to the complete life cycle. So that whereas, you know, the leak detection program is specifically, I suppose, related to how do I do the procedures, and this particular set of guidance is kind of a much bigger basket. But also, you know, on the other hand, it was meant to be accessible to all operators, including small operators. So even if you don't have the staff or the time to go through, frankly, the RP 1175 is pushing 300 pages. You're still able to fairly quickly access the guidance that's being recommended by the technical committee on this project. It's also to try and reduce the documentation and laborious kind of front-end engineering and work that you require before setting up a leak detection system, and to try and introduce a certain level of standardization between pipeline companies, so that you don't have some pipeline companies with absolutely flawless engineering processes and others who pretty much just wing it. The results are documentation. There's a set of reports, basically, and they're supposed to be expert and accessible at the same time and useful in operations. Now, I did mention a little earlier that there are some key issues that are covered here and that are perhaps not quite so well covered in RP 1175. The first thing that every pipeline operator who needs to scope and design a leak detection system is to assess requirements. And this requirements analysis is, and for a long time now people have been emphasizing this, is supposed to be risk-based. So you're supposed to look at your pipeline, analyze by yourself where the risk factors might be and consequence factors might be. And in the light of those, you tailor the leak detection system that you want for yourself. I suppose another key issue which is being emphasized here, and this is something not covered in any of the RP 1175 work, is to explore ways of combining multiple technologies rather than relying on one silver bullet kind of approach, trying to combine multiple complementary technologies into one coherent leak detection system. So there is a lot in here. In fact, I think there's an entire chapter which sort of covers how do you introduce physical redundancy into your system. Another key issue is specifically how do you go about predicting system performance during the design phase. So it's quite difficult today. I did mention the shortage of systematic procedures for external leak detection, for example. And although this isn't a recommended practice itself, there is guidance at least in here about how you might set about doing that. And once more, I kind of emphasize the full life cycle approach. So the full life cycle approach means you're never done. You're always trying to seek improvements. You're always setting yourself stretch goals, and you're always trying to review whether developments in your pipeline or your operations or your staff have had an impact, potential impact on the performance of the leak detection system that might have been specified many years previous. Speaking of this full life cycle, the style of this guidance is kind of a flow chart. This is a snapshot of the flow chart. I don't expect to be able to discuss it in 5 minutes here, but this gives you an idea about, you start with your current condition, which might have or may not have a leak detection system at all. You have down the right-hand side, you have related programs. So it's to be understood that somebody else in the organization will have an integrity management program. Somebody else in the organization will have control room management responsibilities, and someone will have scoped, designed, and placed EFRD on the pipeline, and so on. So current condition places you within your organization as well as within the environment, within the business that's being run by the pipeline. The next step is, like I said, to be hard-nosed about specifying exactly what my requirements are. Am I doing well enough? Do I need to do better? If I need to do better, exactly how much better do I need to do? Which leads to then a selection and design of the leak detection system appropriate to these requirements. And once again, there's tangential issues. There are tangential issues like certain technologies must be maybe pre-qualified by your organization. Do I have requirements related to continuous surveillance, or is intermittent, or is periodic detection sufficient for my requirements? Having finished the selection, I've got an ideal new condition which becomes realized once I install and commission a leak detection system. Then I test it, I maintain it, and this gives me an actual new condition, which I should be able to measure and assess from actual field trials. And of course, this actual new condition becomes my new reality and becomes the feedback loop back to the current condition once again. This is all presented in a series of reports, and so the circles on the right-hand side of the flowchart list the task reports, which break down into the output of this particular R&D. It was liaison, like I said, with a strong industry technical committee. There was liaison with APA, AGA, INGA, AOPL, and so on. I think the other thing is to highlight is that this R&D is manifestly directed not just to the liquids industry, but also to natural gas transportation. So in fact, the parallel set of documentation for natural gas operators, and so there was a specific focus on engaging guys like AGA and INGA on this. We liaised with the API RP 1175 committee, and we also liaised, I'll talk about this in a minute, with the Technical Publication 1149 committee as well. And I did say this a little earlier, the smaller operator can get going with a document which is no more than 10 pages long, and he has, for a lot of the major analysis steps in that flowchart we just went through, at least some templates and go-bys in the form of Excel spreadsheets and Word documents that he can use to get started at least on the road to developing this kind of life cycle approach. The final thing perhaps I'd like to mention is, apart from the natural gas operators, is that there was a definite outreach to very smaller operators. And so there I'm talking about the refinery that has one line which is 5–10 miles long. It just doesn't have time for an elaborate leak detection system program and so forth. And also for the many tens of thousands of miles of upstream multi-phase weathering systems out there, which currently have, again, no leak detection systems on them. At the same time, they have a very difficult kind of problem set. I think the final thing to say is there was explicit coordination with the major state regulators. This was interesting because the state regulators themselves had requirements and questions about leak detection. They are expected to regulate leak detection systems, and many of them themselves need to understand what the whole life cycle approach is. So PHMSA did the state regulators a services right there by allowing them to understand what the processes and best practices were themselves. That's the end of our second topic. Let me just very rapidly check for questions. Looks like we're doing well. No particular questions so far. Once again, if you've just joined recently, if you do have questions or would like a little bit of expansion on any one point, just write it down in your little question bar on the right-hand side of your screen, and I'll be glad during these little breaks between topics to give them an answer. But without much more ado, well, let's move on to the third of our topics, which is the API 1149 publication. API 1149 has actually been around for a very, very long time. It was first published in 1998, I believe, and it's called leak detection uncertainty assessment, which is a slightly obscure name. What it aims to do, well, let me start with the original one. The original API publication 1149 was specifically for flow balance style computational pipeline monitoring, flow in versus flow out leak detection. If your meter out doesn't match your meter in, then the fluid must have gone somewhere else. And the other thing to say about the original API 1149 was that the procedure, first of all, was specifically for crudes and heavier products, so up to gasolines and jet fuels and that kind of thing. So it did not address, it simply didn't have the right approach for addressing HVLs or natural gas. The second thing is, now it does indeed have one chapter addressing what you would do in a transient pipeline operation, but the bulk, the most reliable part of the original publication 1149 related to steady state flow. I would say that the two biggest reasons for this update were trying to understand what would happen if you tried to do CPM in transient operations, and what you do to analyze CPM for HVL systems and for natural gas pipelines. And there's a number of other things too, without reading them all out. There's a number of other uncertainty factors that you can analyze using the update. And these include things like reliability of your metering, performance of your SCADA and telecommunications system, and so on and so forth. In practice, to run the updated procedure, you do need some form of hydraulic model. So the update, I like to call it as really model-based leak detection uncertainty assessment. The other thing to try and say is, rather than aim specifically at sensitivity of the leak detection system, the word uncertainty is used instead, and I'll talk about that a little bit on this slide here as well. So really talking about the third bullet here. One of the objectives in the framework of API Publication 1149 is to try and get away from the definitions of sensitivity that used to be used, and to align them much more tightly to the API Manual of Petroleum Measurement Standards definition. So there's where instruments are defined as having a bias and a precision and a reliability and a repeatability. So so the leak detection system is now becoming much more like a meter than as an obscure kind of black box system. So in other words, we're trying to get to the point where a CPM is really more like any other piece of instrumentation on your pipeline. The other items I think I've already mentioned. I think that the nonlinearity and strong time dependence of the performance is very important. Let's see. I think there's a couple of these have just simply been duplicated. Let's move on. The actual deliverables were an adoption by the API Technical Report 1149, and it was actually published last October. So it's out there and it's ready for use. What is also under development right now, and this will be very useful for the industry, we feel, is custom software which includes a model, so that you don't have to go out and specially purchase separate software and bundle it yourself. There's actually going to be a software tool available by the end of the year, which will allow pipeline operators to run the 1149 procedure themselves without elaborate setup. Quickly to give you a flavor of what the new calculation procedure is that you kind of define three things. The first one is we've already discussed that your biggest factors will be exactly how nonlinear and how transient your pipeline operations really are. So you set up what we call scenarios, and these might be the steady state of the original API 1149, which is the best case scenario. Startups, shutdowns, pump swaps, valve changes, etc. batch schedules. So if you've already got a batch product pipeline, then exactly what the schedule, worst case schedule might be. One thing you can do as well, I think with software for sure, is simply take recorded SCADA. And the recorded SCADA might be just a typical operating day, and that would be your scenario there for including the effects of transient flow in the leak detection performance. The second big area is what are my measurement uncertainties? How good are my instrumentation, and how good is my flow metering? And so you define these as the API Manual of Petroleum Measurement Standards, PHMSA asks you to. So you give each of these a bias and a precision and a reliability number. The final thing is any kind of other engineering factors, unknowns that you might have. So these might be physical data, they might be the actual density of the crude in the line, any impurities in the natural gas in the line, and so on. Things which you think you know to 90% accuracy, but don't, and you can add those as engineering factors as well into the uncertainty calculation. So you can now see, and I'm just going to fly by these because each one is interesting in itself. The output of the 1149 procedure includes, those of you who've used 1149 before will be familiar with the graph on the bottom left. Now the graph on the bottom left, right here, is the traditional sensitivity versus time curve, and you still get that curve. I think more interestingly is that there's this explicit output of the reliability and robustness of your leak detection system. So it does a cumulative probability of failure, not of the pipeline, but of the leak detection CPM system. And some of these outputs are frankly alarming because, of course, there's no point in having an incredibly good sensitivity if the actual reliability of your system is nowhere near that good. And so, in fact, you should be kind of looking at the worst case, I suppose, between these two outputs. I think another important chart is this tornado diagram. The tornado diagram is useful because it tells you which source of uncertainty. Is it the transient nature of the pipeline? Is it the flow metering? Is it the temperature measurement? Is it the pressure measurement? Which of the inputs uncertainties are contributing the most to the total final uncertainty of the leak detection system? And this helps you in design work to decide where to spend your time and energy in improvements. I suppose another file down in the bottom right-hand corner, there's a chart which shows you the contribution of SCADA and telecommunications to the overall performance of the leak detection as well. So in other words, there's a much vaster variety of output reports available from the update than there used to be from the original version of API 1149. That's basically all I really wanted to cover there with API 1149. Like I mentioned earlier, the update can be purchased directly from API already, and perhaps more usefully, I would ask you to look out for the packaged software to become available, I would say January of 2017 or thereabouts. I see no particular questions on the last topic either, which is, I suppose, good news. Once more, if you do have any, just please do go ahead and type them in.
I do have two
and
questions.
I'll be glad to see if I.
Sorry, David. I did see two questions that did come in.
Oh, okay.
A couple more.
Let me see. I think it's just my GoToWebinar is moving very slowly. I'm not seeing them.
Okay, give me 1 second. I'll read these off to you. Let's see. The first one says, does 1149 provide information on addressing uncertainties associated with gas leak detection?
Yes, very good point. Let me re-emphasize this. The updated 1149 covers all fluid types. So it covers everything from a crude, it covers from crude to CO2 to natural gas, and everything in between, HVLs, propane, butane, lines, whatever else is in between. But let me caveat that slightly. There is no question that the calculation becomes more complicated the lighter the fluid becomes. But the answer is yes, indeed. You can analyze natural gas pipelines as well.
Okay, and then I have one more question here, David. It says on slide 22, it's included in the scenarios for API 1149 steady state. What about the transient state?
Oh, yes. Yes, and so a scenario would include any transient state. So the point being, though, that you have to be specific about what that transient state is. So it's not good enough, turns out not to be enough to just say, oh, a transient state that involves a rate of change of line pack of X. Certain transient scenarios are much more toxic to leak detection systems than others are. So a hard pump startup, for example, is much worse than a regulator valve going into operation or a flow pattern changing. So yes, the quick answer is that the scenarios are not just steady state, but any other transient scenario that you might specify, and the fly in the ointment is you have to be fairly specific about when you say transient, you have to say what kind of transient you want to be analyzing.
Looks like that's it on this side.
Sounds good. Thanks very much, Robert. Okay, excellent. Okay. And please keep on watching there. For some reason, my little question screen doesn't show those. Very last part of this, and so we'll be doing this for just about 10 minutes. Is I did want to. Everybody's interested in crystal ball gazing, so let me go ahead. Let me start by going through what I would highlight as what PHMSA regards its responsibilities to be. PHMSA PHMSA requires each operator to maintain integrity management program. PHMSA is also tasked with checking that each operator has an integrity management program, and in their opinion, the integrity management program, the IMP, includes leak detection. So there's always something lost in translation in here. At a large number of pipeline companies, hey, I'd say the majority, integrity management means leak prevention. It's inspection, maintenance, corrosion management, all of that kind of thing. And leak detection is somewhere over there. It's somewhere between automation and control. It might even be IT. So it's important to remember that in PHMSA's opinion, leak detection is part of the integrity management program that it is tasked with checking that every pipeline operator has. Anyway, PHMSA also is required to report to Congress, and it publishes this report first of all to Congress, but also to the public. The way it does this is it goes out and it commissions, first of all, a cross-industry study, which is then for its own purposes, and you can go to the PHMSA website and download them. The last couple were 2007 and 2011. And then it turns that around, puts its name on it, changes a few things, and then makes that the report to Congress. Congress then takes that and uses it in rulemaking. The other thing it does do is many states, let me highlight states like Alaska, California, New York, and North Dakota, for example, have their own set of regulations over and above the federal regulations. So what PHMSA does is, it's not a state agency, but what it will do is go out and help the states to do their own job in inspection and rulemaking there too as well. So that's what PHMSA is for. Now, if PHMSA is authorized by the PIPES Act, and there was a new PIPES Act in 2015, and this is my personal 3 big takeaways. So the 3 big takeaways, I think, apart from a massive amount of gory detail, is that usually PHMSA is funded for a 5-year period. This time it was funded for another 3 years. This was a just budget. PHMSA is not expensive. I think it's mostly an encouragement to industry to engage a little bit more closely with PHMSA, and to for industry to solicit feedback, I suppose, into rulemaking, so that the feeling, let me put it this way, feeling that there's maybe too many recommendations coming out of a little agency bubble, and so more feedback was necessary to comment on some of the possible rulemaking that was coming down the pipeline. I should also say that the flip side is true. So the second bullet is that industry engagement is actually quite slow. And so even though the last PIPES Act was 5 years ago, PHMSA still had not issued 16 of the 42 items in the 2011 PIPES Act that that Congress said they wanted to see. So so I think there's a little bit of backlog there that Congress wants to see cleared within the next 3 years, time frame. The only new technical provisions, now there's a lot of administrative stuff talking about things like reporting requirements and the amount of time allowed to respond to a notice of rulemaking and all of that kind of thing. So there's quite a lot of admin kind of stuff, but but the only new technical provisions relate to underground natural gas storage. In other words, I'm not going to talk about them because there really was nothing new in leak detection in this PIPES Act. There's nothing new, but I did mention that there is this backlog of 16 rulemakings that weren't done since 2011 of which I'm going to cherry pick these 4 because these are the ones that I would suggest are the most relevant to leak detection. So the first one is specifically for new gas transmission pipelines, and I'm abbreviating here. There's a minimum pressure and a minimum throughput exclusion on this, but new high pressure, high volume gas pipelines will need to have automatic and remote control shutoff valves. The second one sounds like it has nothing to do with leak detection, but every pipeline will now have to report MAOP. The fly in the ointment is that there's going to be a minimum MAOP requirement, a minimum MAOP exclusion for leak detection requirements. So you're going to both have to report the MAOP, and if that MAOP is above the exclusion requirements, you will need leak detection. The third one is it used to be that you only had to consider leak detection if you were in a high consequence area. High consequence area as defined by Department of the Environment. This time it's going to have to be everybody's going to need a leak detection regardless. And the words on the final bullet are the kind of words that were asked for by Congress in 2011. So there will be a requirement for operators to use leak detection systems where practicable and to establish standards for the capability of such systems to detect leaks. In other words, you will need to install an LDS if it's practicable, and it will have to meet certain as yet to be defined minimum standards. I think that a lot of these other things are also tangential but not related to the Pipes Act. You can expect a coupling between leak detection systems and control room management. There already is one. So you can expect this to get tighter. I think you can also expect continual improvements to become a factor. It's not just test your leak detection system every 5 years. It's going to be completely review your leak detection system and perhaps upgrade it every year or so. And then the final item, I think, is that there will be requirements for the ready control room operator qualification. There will be probably requirements for operators to be qualified in leak detection systems too. I think that you can also expect documentation of the engineering design of the leak detection system to be beefed up. So, in other words, did I do API RP1130? Show me how. Did you select instrumentation? Show me how. Did you use external sensors? Okay, why and how did you go about it? So documentation of the detailed engineering design, I think, is something that you can expect to see in the next rulemaking cycle. That's all I had, gentlemen. Thank you very much for participating. Robert, were there any final questions?
I don't see any additional
while
questions.
I was talking.
No, I don't see any coming up so far.
That sounds fine. We're just about on schedule, and so yes, thanks again, folks, for attending. I do sincerely hope if you do have any other questions, either on any of those 4 topics that we talked about during this webinar, the other items related to leak detection, please do reach out to either myself, contact detail right here on the slide, or to Robert, of course, who can always get hold of me. So with that, with thanks, I'll call this webinar to a close.
Okay. Thank you again, everyone, for joining us today. And like David said, we're going to go ahead and closing this webinar out. And thanks again.